Venus destroys machines fast. Surface heat hits 465 degrees Celsius and crushes metal under 90 times Earth's air pressure. No lander should survive long enough to catch anything unusual. Yet in 1982, a Soviet probe outlasted its own design limits by hours, and its cameras kept scanning long after they were built to quit. What they caught still has no clean explanation. Venus is not a friendly place to send a camera. The surface sits under a thick blanket of carbon dioxide with clouds made of sulfuric acid, and the ground temperature stays around 465 degrees Celsius, hot enough to melt lead. The air pressure at the surface is about 90 times what you feel standing at sea level on Earth, roughly the same crushing force a submarine hull deals with almost 900 meters underwater. No electronics built by humans last long in conditions like that. The Soviet Union spent decades trying anyway. Between 1975 and 1985, a series of spacecraft called the Venera program managed to land on Venus and send back data before dying, sometimes within minutes of touching down. Venera 13 was one of the last and most successful of these missions. It launched in late 1981, and on March 1, 1982, it dropped through the clouds and set down in a region called Phoebe Regio. Engineers had built it to survive just 32 minutes on the surface. It ended up lasting 127 minutes, almost 4 times longer than planned, drilling into the ground, testing a soil sample, and firing off panoramic photographs before the heat finally won. That extra survival time is the reason we have as much data as we do, but it also meant the cameras kept scanning long enough to catch something that has puzzled people for over 40 years. Venera 13 was not just sitting there taking pictures. It landed at a spot near 7.5 degrees south, 303 degrees east, on the eastern edge of Phoebe Regio, and it carried a full kit of scientific instruments packed inside a sealed titanium pressure vessel. Along with its twin cameras, it had a mechanical drill arm built to grind into the surface, lift a sample through a small airlock, and feed it into a chamber for analysis by an X-ray fluorescence spectrometer. That drill had to survive the same 465 degrees Celsius heat and 90 atmospheres of pressure as everything else on the lander, and it still worked well enough to bring back a real answer. The soil sample turned out to be alkali basalt, a type of volcanic rock. 4 days later, its twin lander, Venera 14, touched down about 950 kilometers away and drilled a different kind of basalt called tholeiitic basalt, more similar to the rock found on Earth's ocean floor. Together, the two samples told scientists that Venus had gone through major volcanic activity in its past, reshaping large parts of its surface. Venera 13 even carried a microphone that picked up low-frequency vibrations from gusts of Venusian wind, which counts as the first audio ever recorded on another planet. All of this hardware and data collection was happening at the same time the cameras were slowly scanning the landscape, line by line, building up the panoramas that would later spark the whole Scorpion debate. The drilling, the soil analysis, and the imaging were all fighting the same clock, and every one of those systems was pushing against a design life that nobody expected the lander to beat by nearly 4 times over. The cameras on Venera 13 did not work like a normal camera that captures a whole scene in an instant. They used a mechanical scanning system that built up each image line by line, sweeping across the landscape over a period of several minutes. 2 of these cameras sat on opposite sides of the lander, each looking out through a thick quartz window designed to survive the crushing pressure outside. Because the image built up slowly over time, anything that changed position or shape while the camera was scanning would show up as a strange or distorted shape in the final picture. This detail matters a lot for what comes next, because it means the pictures were never a clean snapshot of a single frozen moment. They were more like a slow-motion recording stretched out and squeezed into a single still image. Each frame was scanned in black and white through separate red, green, and blue filters, one after another, and engineers back on Earth combined those separate scans into a single, full-color image once the data arrived. That process alone took time and careful reconstruction. It also meant the color panoramas people usually see today were not raw camera output. They were assembled afterward from several black and white passes, which adds one more layer between what actually happened on the surface and what ended up in the final picture people study today. If you're enjoying this breakdown, hit subscribe so you don't miss where this bracket goes next. The panoramas. Venera 13 sent back showed a flat plane covered in orange-lit basalt rock, lit by the strange orange glow that filters down through Venus's thick atmosphere, since the clouds filter out most of the blue light before it ever reaches the ground. For years, scientists mostly studied the rocks, the color data, and the chemical readings from the drill. Then, 3 decades later, someone went back and looked at the same old pictures with fresh eyes and found something that had been sitting there the whole time. In 2012, 30 years after Venera 13 landed, a senior researcher named Leonid Ksanfomality published a paper in the journal Solar System Research, sometimes also known by its Russian name Astronomicheski Vestnik. Ksanfomality was not some outsider chasing headlines. He worked at the Space Research Institute of the Russian Academy of Sciences and had actually contributed to the Venera missions back in the 1970s and the 1980s. This was a person who understood the hardware and the mission better than almost anyone alive. Ksanfomality went back through the raw panorama images from Venera 13 and identified several objects he thought looked unusual. He gave them simple, almost casual names. One was called the disk, another was called the black rag. The most talked about was a shape he called the scorpion. According to his analysis, these objects appeared to change position, shape, or visibility between different frames taken at different points during the landing. His conclusion was bold. He suggested that the shapes showed enough features in common with living organisms that it was worth considering they might actually be some form of life adapted to survive on the surface of Venus. That is a massive claim, and it is exactly the kind of claim that demands serious scrutiny before anyone accepts it. The scorpion shape in particular became the center of the whole debate. The story of the scorpion object is genuinely strange when you lay out the timeline. Right after Venera 13 touched down, its landing impact disturbed the soil, throwing dust and material sideways because the lander was moving slightly to one side as it came down. Early images taken just minutes after landing show a shallow, oblong groove in that disturbed dirt, roughly 100 millimeters long. By around the 20-minute mark, that groove appeared to have grown, with raised ridges along its sides, now closer to 150 millimeters. Then, somewhere between the 59th and 90th minute after landing, a more structured, defined shape had emerged from that same spot, eventually becoming fully visible in the frame taken by the V13-1 camera. Then, by the 119th minute, the object was gone from the image entirely, as if it had left the frame. Ksanfomality argued this pattern, appearing, growing, taking a defined shape, and then disappearing, looked like the behavior of something alive rather than a static rock or a piece of debris. It is a genuinely eerie sequence when you look at the images side by side. But a sequence that looks eerie is not the same thing as proof, and that is where the rest of the scientific community stepped in. The response from the wider planetary science community was fast and mostly skeptical. NASA and independent researchers who studied the same images offered a much simpler explanation for at least some of the objects Ksanfomality described. The disc-shaped object, for example, was identified as a lens cap. Venera 13's cameras, like earlier probes in the series, had protective covers over their lenses that were designed to pop off after landing, so the cameras could see the surface clearly. There is a well-known detail that backs this up. On Venera 14, a sister probe, one of these lens caps happened to fall directly onto the spot where a spring-loaded arm was supposed to touch the ground to measure how compressible the soil was. Instead of measuring Venusian dirt, that instrument ended up measuring the compressibility of a piece of Soviet camera hardware. Once you know lens caps were popping off and landing randomly near the probes, an object that looks like a disc and shows up in different spots between photos stops looking mysterious and starts looking like ordinary hardware debris. This kind of mishap was not unique to one probe. Because both Venera 13 and Venera 14 used pyrotechnic bolts to blow the lens caps off right after touchdown, both landers ended up with loose, semicircular pieces of hardware scattered somewhere in view of their own cameras. Photos from the missions clearly showed these discarded lens covers sitting on the ground next to the lander itself. Anyone comparing frames without knowing this detail could easily mistake a lens cap sitting at a slightly different angle, or in a different lighting condition, for an object that has physically moved. The scorpion shape got a slightly different explanation, though it points in the same direction. Researchers who examined the raw data closely, including independent analyst Don P. Mitchell, argued that the scanning camera system itself could produce shapes that look structured but are actually artifacts of how the image was transmitted and assembled. The camera sent data back using a pulse code system, and errors or quirks in that transmission process could create small, misleading patterns in the final image. Some of what looked like a moving object may have simply been a byproduct of how digital noise interacted with the scanning process, mixed together with the very real disturbed soil and scattered rocks sitting right where the object appeared. Even the researchers who took the Venus life idea seriously enough to study it carefully leaned toward the artifact explanation once all the pieces were laid out. Disturbed soil, popped lens caps, and quirks in a decades-old scanning camera system offer a far simpler explanation than living creatures surviving on a planet where the surface is hot enough to melt lead. Simpler explanations are not automatically the correct ones, but in science, they are usually the ones that hold up once independent teams check the work. It helps to step back and remember how many separate strange objects Xanthophyll Malady and later researchers pointed to. Follow-up work, including a detailed reanalysis published years later, that reprocessed the old Venera archive data with modern techniques, identified as many as 15 different objects across multiple missions, not just Venera 13, but also Venera 9, 10, and 14, that someone had flagged as possible signs of unusual activity. That is a lot of individual claims, and each one needs to be checked on its own. Some of these objects were only visible in a single panorama and completely absent from every other image taken of the same spot, including images taken from a slightly different angle by the second camera on the same lander. That kind of inconsistency is a big warning sign. If something is a real physical object sitting on the ground, it should generally still be visible, even faintly, from a different camera angle looking at roughly the same patch of surface. When an object shows up in exactly one frame and nowhere else, that pattern fits an imagining artifact far better than it fits a living creature that just happens to only appear once. None of this proves with total certainty that nothing unusual was ever near those landers. What it does show is that the burden of a proof for a claim this big has not been met. Extraordinary claims like discovering alien life require extraordinarily solid evidence, and shapes appearing in a scanning camera system known to produce artifacts do not clear that bar on their own. Put everything together and the Venera 13 mystery becomes a lesson in how tricky it is to interpret data from a world nobody fully understands. A respected scientist who helped build the mission looked at real data and saw something that looked alive. Independent researchers checked the same images and found lens caps, disturbed dirt, and camera artifacts that explained almost everything he pointed to. Both sides studied identical raw pictures, and the disagreement came down to interpreting shapes and images never designed to answer that question. It also helps to remember how limited our view of Venus really is. Every surface photograph ever taken came from Soviet landers between 1975 and 1985, and their combined survival time adds up to less than 9 hours across an entire decade. Everything since, including NASA's Magellan radar mapping and newer JAXA and ESA cloud studies, has stayed safely above the surface. No spacecraft has gone back to check the spot where the Scorpion once appeared, and none is scheduled to. The debate remains stuck where it has been for over a decade, resting on a handful of grainy, decades-old photographs. Whatever those cameras really captured back in 1982, Venera 13 still sits on that same patch of Venus today, waiting for an answer nobody has gone back to find. If this video gave you something, subscribing takes 3 seconds, and it helps us keep making content like this.